So today we will be discussing about Apache Nifi and the training curriculum. So let us start with our introduction. So first thing is about MindMajix. So MindMajix has been around 10 plus years in the industry. So MindMajix is providing a course-based training, both self-paced learning and as well as trainer-based learning. So it has been almost 450k plus of professionals has been got trained and certified with MindMajix. So MindMajix provide cutting edge technologies with experienced professionals, trainers, and certified trainers. MindMajix has 110 plus kind of reputed corporates around the globe. I have been working as a senior data engineer. I have worked with successful startups and many more top MNCs, and I have been certified as a cloud data engineer. I have been given training since 5 plus years for both the students and as well as working professionals. So today our core agenda is about discussing about Apache Nifi. So first thing comes here is like what is Apache Nifi? Why do we need Apache Nifi in the first place as an enterprise model? Second thing is when we have to use Apache Nifi and when we should not use an Apache Nifi. And we will be discussing about the course curriculum, what will be covered during this complete course tenure, and we will be discussing about the multiple projects we will be handling during these sessions. So coming to the first topic, Apache Nifi. So what is it? So as the definition itself states in the official site, so Apache Nifi is an easy to use, powerful, and reliable system to process and distribute data. So let us take an example. So now the data has been evolved a lot. Let us take a multiple systems acting inside an enterprise architecture. So we need to transfer a data from system A to system B. A system A is completely decoupled from system B, means both the systems can evolve individually. Let's say if the requirement or the data model or the transformation model or the scalability between these systems keep on evolving, then what is the problem statement over here is we should be keep on changing we should keep on changing these methodologies, how we scale the applications, how the data is flowing individually. That is the problem statement which Apache Nifi is going to solve us. So Apache Nifi has been open sourced, and it uses FBP as a programming model, flow based programming. And now the Apache Nifi has a process, and what we will do, we design the systems, and the source system and the destination system will be capable enough to transform the data in a scalable. To keep it simply, Nifi was built to automate and manage the flow between multiple systems. Okay, so now here comes why only Apache Nifi. So are there any other competitive tools we have? Why someone should handpick the Apache Nifi? So as when we discuss on this data transferring model, so there will be like a lot of enterprise challenges happening. The first foremost thing is system fails. So each system evolves its own individual way, its own individual kind of a fast-paced manner. So now my system or should not be depending upon my upper systems or downstream systems. Each individual evaluation should happen and data should never get down. And this data which we are talking is a big data over here. So I should be able to scale my system horizontally so that things will never get breakdown. So now coming to this different rates, what we discuss is systems evolve at a different rates. Let us take an example. Now my use case is to listen to the Twitter API. So Twitter itself has shows millions of requests will come. Now let's think about an analytical use case where I'm sitting in my location and I wanted to listen to all the trending hashtags over the Twitter API. Now in order to transfer this data and do this analytics to my analytics system, I should have a capability where I should maintain this back pressure where Twitter is running in a different rate and my architecture or my component is acting at a different rate. Now, NiFi will sit in between both the systems. And it has capability to manage both the different rates and maintain the back pressure and make the data stream pipeline seamlessly easy. And the next problem statement, what we quite often face while doing these data flow operations is accessing this capacity to consume. Let's say in the similar kind of use case, I'm consuming the data, but because of some alternative issues or some scalability issues, my component is not able to catch up all the back pressure given by this Twitter API. Now, what is the thing I have to do? I need to reprocess the data, or I should have the capability to start the data or read the data from where I start. So these sort of issues will be out of the box solved by the knifing. The foremost thing is continuous improvement occurs in the production. So when we say, okay, so I'm listening to a system A and system B is actually doing this consumption and doing this analytics process. When system A started generating data from XML to JSON, from other format, maybe CSV to the CSV format. If the system is keep on evolving, then the immediate thing is that the consumer at the system B side should also be keep on changing in the production. And when the space is really fast in the real time, so to do this testing, to do the environment kind of changes, to do the start the system B to start listening all to these consumers and do the development and all, so this will take a lot of efforts and testing efforts, and we will never meet the ROIs. For the reason what Apache Nifi do, it has this extensible kind of architecture, so where we can write a custom processor which can be used at n number of places. And this has been designed as an open source, in the sense, like, let's say if one developer is actually solving this problem, all the other developers can actually use it instead of writing the code from very scratch. So, and coming to the scalability issues, Apache Nifi is designed to run either the standalone mode or at the cluster mode. Think about a system, when we just started our project. We have system A and we have system B, and so we system A and system B, the data flow is happening in the order of megabytes per second or megabytes per minute. Then a single system can actually handle that particular load. Let's say if my application got increased, that the inflow data got increased drastically, maybe we got a scale up to a terabytes or petabytes kind of data scale, then obviously my system should be capable enough to scale. And Nifi is such tool where scalability is out of the box. Let's say if I wanted to start my development, or if I wanted to start my project in my applications, or if I wanted to do the development process, I can do with a single Nifi instance, and immediately I can scale it to in hundreds and thousands of instances. What is the benefit? What we are getting is I will have zero downtime. So Nifi follows something called as horizontal scalability. Usually the scalability of two different types. One, horizontal scalability. Second thing is vertical scalability. So we have this flexibility within Nifi is horizontal scalable. So we have a system running over here. Okay, so we consider this in a cluster mode, we have a zookeeper which handle all the stuff. Now let's say I have a single instance which is able to capture maybe 1 MB per second kind of data, and down the line I suddenly got maybe 100 MB per second kind of data. With zero time, I can just spin up more instances, more Nifi instances, and those things can attach to the same master. We call him as a zookeeper, and all the data pipeline will scale from one instance to 100 instances or a number of instances. The methodology here, what Nifi is actually following, is horizontal scalability. When it comes to vertical scalability, the downside is we need to make a restart of Nifi. Let's say the model how it look like is like something like this. I have a master, or I have a system. Now I have all the instances following as a kind of sequential pattern. Now let's say everything is actually connected to a master. Now down the line something went down, or I wanted to scale this up, I need to make the complete system restart, which is a kind sort of downside with the vertical scaling. But here comes with an FA where it is highly scalable out of the box with horizontal scalability. And the other best feature what we have is we have web-based kind of drag and drop user interfaces. So it is very hard to understand. Let's say if I wanted to connect multiple systems, and if it is a point system A and system B, always it is simpler. When we relate to the real-time use cases where we have a number of producers and a number of consumers, and there should be transformations involved, then it will be really hard to maintain such kind of interface, to make a complete track at a single view. But Nifi comes here where it solves the problem statement by producing a good UI where it shows all the processors involved, and it will show the data flow happening, how the data flow started and how the data flow ends. A complete intuitive kind of interface it will show with a good graphical user interface. And when it comes to configurability, let's say I have a simple use case of reading a file or transferring a file. Now this file format can be n number of types. Let's say I started with a plain text file. Now suddenly my system got evolved, and I started generating data with CSV data, and then I just generated starting data with JSON data, or I just got XML data. So my system should be configurable enough to play around with the knobs. So I configure something with zero downtime or with immediate effect, those should come and get affected. And the same configurability when coming to the throughput. Let's say if I wanted to increase number of threads acting, When we are dealing with the big data, then obviously we need more and more kind of compute power needed when doing these transformations. But let's think about this threaded way, multi-threaded way. Now let's say we have a single hardware. Maybe my hardware have one core or two core. Depending upon my cores, my number of threads acting is directly proportional. Let's say if my input rate is actually increasing, then the transformation should also get increased, so that only there will be a minimal back pressure happen. So in order to increase them, I have this configurability at each processor level. You change the number of threads or you change the back pressure, you immediately will get affected, and the transformation we will see in a real time. The NiFi data flow which we define will just keep on scaling up. And coming to this extensibility, so as we already discussed, so NiFi is already made as an open source tool. Okay, so now the best part on this extension, how the NiFi is designed is, so we have everything as a kind of processor. Think about the use case. You're trying to read a data from a Kafka, and you wanted to outsource it to some Elasticsearch, or you wanted to outsource it to a file or S3 or a number of data source in such case. Okay, now if I have this use case in my project for a number of use cases for a single project or for a single company, so what happens is we write a single code and that will be used across the different use cases. Same thing happens, but the use cases or the usage it's at the global level, because it is open source and it has it developed in an extensibility architecture. So what happens is we define a processor and we open source it to the Apache Nifi, or we prepare them as an NAR files. And we have the NAR files, or we coded them for once by following the standards provided by Nifi. Then we can use this for globally a number of use cases. Even if someone else developed this processor, but they put them in the Nifi, or we got the NAR file, we can directly deploy, or we can copy the NAR file directly into our in our Nifi source files or library files. And once we make a quick restart, then we will start seeing those things directly on our NiFi processors. We will be able to see them practically. And when this extension, designing of this extensible kind of processes come into place, NiFi has provided a good number of best practices or good number of things to follow. So we will be covering all of them one by one in our curriculum. But so this is the one of the best use case where NiFi is actually getting the popularity. Write once, write the NAR file or build the code once and use them across the world, across the use cases seamlessly. And when coming to the security, so for any enterprise model of use cases, security is the first preference they use. Okay, let's say if we wrote a code and I needed to take the security for each and individual component, that is not an easy job. But NiFi, it comes with an it enables an architecture where it gives the security out of the box. And as we have these processes as a unit of computation, then we define a processor. We follow the standards of NiFi. We create the NAR files or we create the processors, and those will come or those will work with the security predefined with this NiFi architecture. We will be seeing how we can play around with the security. Let's say if one processor is listening to this HTTP or HTTPS, how we can configure all those TTL certificates and all. So that is the best use case we will be seeing. But considering all these challenges which are coming from out in the regular enterprise model, NiFi is there to solve all those problems out of the box with simple, easy way of configuring them with the user interfaces and playing around with them. And next comes the use case of stating when we have to use NiFi and when we should not use NiFi, because one single tool cannot solve all each and every problem in the industry. So there will be some sort of downsides for every individual tool. Apache NiFi is good for sorting out some sort of issues, or best for some use cases, and it is not best for some other use cases. So it is important for us to understand when in for a given use case in a real world scenario, I need to figure it out. Yeah, this is the best pick for the NiFi, or it is not a best pick for Apache NiFi. So now let us try to understand at high level when I have to pick Apache NiFi. So Apache NiFi, in the definition itself, we understand. So it is an automated data pipeline. I configure it once, I connect the source systems to the destination systems, I do the transformation, I handpick the transformation logics, and it is automated. Let's say that is your sort of use case. I have a system A, I have system B, like we could say like source and destination. In between, I have like so many of transformations involved, but everything should get automated to from a raw material from raw data to then analytical platform. Then this is the use case of Apache Nifi. We can go for Apache Nifi, take the out of the box processors. If out of the box processor is not working for us, then obviously we can write our own custom processor, and then we can prepare the data flow and generate it as a template, and we can use it. So that use cases Apache Nifi will fit for us. The other use case is enrichment and preparation of data. Now if we see, the complete world is moving towards the artificial intelligence and machine learning. Let's say every information what we generated is kind of either semi-structured data or unstructured data. Then it is important for us to make or convert those things into structured data. Once we have the structured data or meaningful data, then and there only we can perform a good sort of machine learning algorithms on them, and then we will get a better results or predictions on sort of them. In order to convert this semi-structured data or unstructured data to a perfect structured data, in a real world situations, we have to talk to the other systems, or we have to prepare the data which my analytics engine actually needed. So that is where Apache Nifi transformations will come into place. We have out of the box many processors, we configure them, we enrich the data, and we will prepare the data. One better example, or a simple scenario over here is, let's say we are dealing with some e-commerce sites, maybe Amazon. So let's say we got an order tracking. Now for order tracking usually taken by third parties. Let's say some third party vendors are actually doing this logistics. Now I have this Amazon e-commerce mobile app, okay, where my core system is there, and I have this third party system where they are doing this actual delivery. So there should be an interaction between these two. Let's say down the line, I have to perform some sort of analytics. So for, on customer based, how the customer behavior is there, how he is doing the orders and all, or where how fast he is actually interested in getting those orders getting delivered. Or I wanted to make an analytics on sort of this delivery engine, how like how even in order to increase the sales, I needed to increase the customer satisfaction. If the customer is not satisfied with the delivery front, I needed to perform some analysis. Then in order to extract some run some AIML recommendations, or run some behavior analysis, I need a proper data. But think in a situation, so this is an identical entity, I will have information about an order, but I don't have complete information about how the orders are making, or who is happening, or where the exact product is, or in which state or which stage actually the order took more time to get delivered. So such kind of information I will not. Same with this entity, I don't have user information, I don't have order information, so there is something called as queues. So usually, so I don't have such sort of information. Then there should be an interaction between both the entities, so that only I will get some meaningful data. And once I got the complete meaningful data, then my AML algorithm or my analytics platform will be able to generate some sort of good information. So that is where the enrichment and preparation of data enrichment actually takes more place. Now I needed to interact with the system, asking, okay, so this is our order ID, and I need more information of order journey from your system. Then it will produce, okay, so here goes your required information. Then I will get this information, this we call them as like enriched. So I have maybe I have a simple JSON, I will have this enriched data. Now I have this JSON called as enriched JSON. So I will use this JSON to push to the analytic platform. Okay, in such sort of use case, Nifi will plays major role. Why? Because again, coming to the same way, so this system will query in a different manner. Like asking is very simple. I can ask thousand queries per second, or 1 million queries per second. But in order to answer them, this system actually needs some time to answer it. I needed to go check the database, fetch the relevant data, and produce it as a response, and then you can generate it as a response. Now if you see, when we have this as a use case, the data size over here, or the back pressure here, will keep on increasing. Now I need a system which acts between this system A and system B, which should be capable enough for the configurability, for the scalability, and to handle the back pressures. And if you think about that is your problem statement, and Nifi has all those problems solved as an out of the box. In such use cases, yeah, Apache Nifi is best. And the second thing is, and we already discussed, let's say this entity is of Amazon, this entity is of some third party. Then important aspect is what is about the security, how reliable the platform is. If someone is actually asking me, I need to get understand, okay, this is Amazon. If someone is actually giving me response, I should understand, okay, so this is company XYZ. So such side of reliability and security is needed when we have a complete different or remote entities. And NiFi comes with the security protocols which is enabled out of the box, and that will solve a lot of issues. Okay, so now we understand when to go for Apache NiFi. Same way, we have some use cases when Apache NiFi is not a best case for us. What are those use cases? And the first and foremost use case is distributed computing. When we have seen the definition of Apache NiFi, so there we say it is for distributed transferring of data, but they never mention it is distributed computation. So there is different use cases. For example, let us consider popular framework called as Apache Spark, which is again an Apache open sourced one, but this guy actually does the distributed computation. Let's say again, think about the similar way. I have this data, I needed to compute this data in a distributed way. Okay, where I have like a number of systems, I needed to compute them, maybe performing a join operation, or do the shuffle and all, aggregate the data and produce a report. If this is your use case, then Apache NiFi is not for us. We have some different sort of frameworks called as Apache Spark, Apache Flink, different sort of things. But NiFi is a data connecting platform, not a computation platform. Even it is distributed, it is like a scalable, it has master slave architecture. But Apache NiFi is not for computation. We do the transformation, but we don't do the computation in a distributed fashion. If the distributed computation is your use case, NiFi is not the best fit for us. What else we have? Let's say we have complex event processing. So these days everyone is actually going for the event driven kind of frameworks or event driven kind of architectures. But let's say if it is like a complex event processing, in the sense I will do some sort of work when something has already happened, or else I won't do this one. I will park this as a secondary one, or I will just halt this event. If my event is actually depending upon some step of actions or some workflow, I could say, then Apache NiFi is not for us. We define the data pipelines in such a way it will be scalable enough, distributed enough, but it is not a workflow based. Okay, so that is not the use case for Apache NiFi. And the same way, when we need joins, when we wanted to perform windows or tumbling operations, windows are tumbling such a way, let's say here in a real time. So this is the time frame of data. Event happen, or the data generated at 11:45, 11:50, 11:55. So there will be some sort of use cases. Maybe think about the credit card transactions, okay, where we wanted to generate the anomaly detection sort of things. Then in such kind of use cases, NiFi won't work for us, because they need a tumbling operation or windowing operation, in the sense what is the behavior of the data in previous 10 minutes or in previous 5 minutes. From the current point of time, go to the previous 5 minutes and generate the analysis or prepare the analysis, and now let us decide what is thing happen. So if such sort of use case is there, then Apache NiFi is not for us. We have some separate sort of tools where all these things will get handled, but Apache NiFi is not such use case for us. We got better understanding what is Apache NiFi, when to go for Apache NiFi, when not to go for Apache NiFi, and what is the problem statement Apache NiFi is actually getting solved. There is lot of information is there where we will discuss during our course about the FBP flow based kind of things, and we will be discussing about more data flow challenges, maybe the challenges of infrastructure, or the challenging of formats, data standards, or the requirement changes. We call them as velocity changes. So all sort of things we will be discussing one by one during the course, but as a demo, so this is what Apache NiFi, and we need to go for Apache NiFi for so and so kind of features, and we should not go if so and so is our use cases. So let us cover the curriculum, what we are going to discuss during our complete training. As we said, Apache NiFi will get even more better hands-on. So what are the key features and what are the deliveries or the guarantees it is offering for us? So we will go one level more depth, and we will try to understand it. And most importantly, we will see the concepts of Apache NiFi, like a kind of basic concepts to the advanced concepts, understanding the base terminologies what Apache NiFi is. when we say like FBP as our platform, but FBP actually has like flow-based programming has different terminologies. NiFi is purely based out of flow-based programming, but our NiFi people has renamed those terminologies. Let's say in FBP we have something called as information pack, but we call them as like flow file in our NiFi terms. Same like in FBP terminologies, we call something called as schedulers, but in NiFi we call them as flow controllers. So there are like a kind of hand-to-hand different terminologies. The concept is quite same, but the terminologies are different. So it is mandatory for us. Let's say when we are mastering the Apache NiFi, we need to understand what is flow-based programming, so that we can understand, we can correlate our terminologies with the flow-based programming, and we can master on the core concepts. And we will be starting with the installations of Apache Nifi, which is a few clicks away, and we will do the hello world kind of things. Means let us start in Apache Nifi, and we will do the traditional thing: copy a file from source location to a copy a file from destination locations, and which like folder copy to destination copy, and everything will be in a standalone. We will see them as in hello world to get understanding the user interfaces and all. And then we will go to the NiFi basics. Okay, so again, as we said, like there are terminologies which needs to be there, and there are some key features or the key components. Those terminologies needs to be get understanding. So we will be seeing what are those basics. Immediately we will be switching back to the hands-on, where we'll have this good user interface. We'll play around with some processors, do some ETL jobs. And then once we got a better understanding on the terminologies and the components and the user interface, then we'll go to one more level depth of architecture. So where we can visualize, once we have this practically seen the NiFi, use them, and once if someone says the architecture, then we'll get the better understanding. Okay, so this is how the flows are happening. So we'll go in depth of architecture, how Apache NiFi has been designed. Then we will be discussing about the advanced concepts. Let's say if you wanted to deal with the registries, or if you wanted to deal with the control files, or if you wanted to go with the processor back pressure settings. So those concepts will come, and we will be discussing them in depth and practically. And coming to a real world scenario, NiFi solves many things out of the box. Let's say if let's say we have this data flow, but the data flow itself is keep on evolving, and I have a huge data engineering team, and the data engineering team needs to solve like a team A made some changes, and they wanted to test their changes, and team B is like individually testing their own data flow feature. But there should be some sort of a registry or version controlling on my data flow, how the version control is happening. If something went wrong, we are able to roll back the changes. Same stuff in the data flow template as well. I need to have a capability to track the changes happening to my template file. Down the line, if something went wrong, immediately I need to select the version, I need to roll back it, so that my production will have minimal downtime. So such sort of thing, to handle such sort of things, Apache NiFi has introduced down the line some a new module called as registry version control, and this is quite important. So in the real world scenario, if someone is actually developing the templates or maintaining them, we mostly done the stuff from the version control itself. And importantly, the monitoring stuff. I defined a template, but I needed to monitor how my template is actually performing. So NiFi has a good user interface where it will show processor level or template level kind of monitoring, but we will see them practically how to get more meaningful insights from the data which NiFi is showing. Same way this is quite important in real world scenarios. Even though Apache NiFi is open source and everyone is actually contributing to Apache NiFi since from very long time, still there will be some use cases where a out of the box processor may not be available. Then we need to write our own custom processor. As we said, this will be the major kind of 50% of work happening with Apache NiFi developer job, where I have the use case, or even though if out of the box some processor is there that may not be serving good for my particular use case, then I need to take their own code, take the code from Git. I need to do I need to do generate the custom processor from the very scratch. So we will be morely stressing on this, how to create a custom processor, or how to establish the NAR files, or how to contribute to the GitHub also. And everything what we discussed is purely practical based. Why? Because Apache NiFi itself is a practical based of tool, where we have the good user interface and many more options, which allows the user to spend more time on the UI, and we can do a lot of stuff. So we'll be seeing them down the line. So these are the high level kind of things what we will be doing down the line, and we will be seeing the standalone mode and as well as the cluster mode. And the duration of course will be around 30 hours of time. And so other important stuff, we can contact the MindMajix people and they can give the details for us. Same way, once we had this course completed, then MindMajix will be providing the course completion certification. And if some people are actually interested to go beyond the Apache Nifi training and MindMajix certification, if they wanted to see, we used to have a certification, but now that has been under maintenance. And like a Hortonworks has a Nifi certification, but Cloudera guys bought Horton Workspace, and right now they are revisiting all their certifications. It may take some time to get stabilized, but near future this course content will be quite enough to get certified, like Cloudera certified Apache Nifi as. And when it comes to the practical based use cases, as we discussed, we start with a file copy from very basic of hello world thing from source to destination, and immediately we'll switch back to our big data kind of components. Let's say I have a text file, I wanted to flush the data to Kafka by doing some transformations, where Kafka is really this became a major component in current architectures, big data architectures. Without Kafka or without Kinesis or RabbitMQ, such kind of pub sub models, if we don't have them, then we are not able to make the application success. So these components are so much important for us to get hands on. So we will be handpicking Kafka, which is like again Apache open sourced one, and it is quite famous PubSub model which provides a lot of features, and we will be dealing with Apache Kafka. For our project purpose, we don't need more knowledge in Apache Kafka, but the basics will be covered during the course itself. How to download or how to run the things, what are the minimal technologies we have with Kafka, those things will get covered. And if we see the current trend of how the IT industry has been evolved, everything is cloud based. So previously what we used to do, we have HDFS or Hadoop file system as a kind of a good to go file system if I have big data storage needs. But right now, considering the operations based or considering the cost things, everyone is going to cloud or blob storages, which is like advanced of HDFS, or we could say like cloud managed HDFS, I could say. So one of the best option or the cheapest option we have is S3, which is a blob storage provided by AWS as a cloud service provider. We will be practicing this Kafka. Once we got data generated to Kafka, then we will write a data flow where we will copy the Kafka topics data to the relevant S3 bucket. Okay. Same way, when we are dealing with multiple systems, everything, the data over the wire is getting transferred from one remote location to another remote location is mostly on the bytes. There will be encoding mechanisms, under decoding mechanisms, or encryptions and decryptions happening behind the scenes. And there is one out of the box basics for kind of encryption decryption with the Nifi, but there is no proper AWS KMS kind of encryptions, which is really popular these days. We don't have anything out of the box. So what we do, we write our own custom processor. Maybe the use case could be anything, user interest, or else we will write one use case where we use AWS KMS as an encryption service, and we will write our own custom processor, and we will deal with the encryption decryption project as well. So there will be a lot more use cases, but to give a brief, so these are the few projects which we will be dealing with. And coming to the training or lab setup, so Apache Nifi is good enough to run in a single Windows machine or in a cluster of machines. As we said, so for a developer or for a DevOps guy to quickly test or get the hands dirty with the Apache Nifi, a minimum Windows 7 system or Windows 10 should be quite enough with the 4 GB of RAM and 20 GB hard disk. If we have Windows 10 as an operating system, the best suggestion which we would give is go and install the Ubuntu WSL, which is provided by Store, and this is the kind how WSL look like. This is like Windows subsystem for Linux. WSL stands for. So in the sense, like on the Windows itself, I don't need a dual boot of operating system. I can run the Linux on top of Windows 10 itself. So this is very good because in a real world, if we see, we use the Linux or Ubuntu kind of systems mostly, and we won't use Windows as a service mostly. So if we have this WSL installed on the Windows machines and we have the Nifi flavor download and running, then we can use those commands, and those commands will be hands-on for your production purpose as well. If you have a Mac operating system, then 4 GB RAM with 20 GB of hard disk is good enough. If you're interested to go one level ahead and see how to deal the things with the cloud, then we need an AWS free tier account is sufficient for us. We will have 750 hours of free compute power. We can spin up one or two or three maybe EC2 instances of minimal T2 micro or T3 micro. Then we can run multiple NiFi instances, and maybe if you wanted to try it out, we can try the cluster setup as well, which is happening right now. Everyone is going for cloud. This will be a better use case. We can have any of these setup. Yeah, so the best pick is if for development or for the initial purpose phase, Windows Linux subsystem or Mac, anything is sufficient. And going forward to test the cluster setup and all, AWS free account is good enough, where we have this putty from like kind of connector, and we will connect to the instances, EC2 instances, and we will run the commands. And when coming to the additional course resources, so we will provide you better resources like a kind of study materials whenever needed, and everything will be kind of practical based. But if you wanted to go even more depth, so we have we are providing these links, so where we can go and see the documentation. So this documentation, it would be the best starting point to understand NiFi, a developer kind of introduction. If you are interested to see what are the roadmap Apache Nifi is, what are the new releases we have, if you wanted to go with feature by feature, then this blog serves us better. And we will provide all the better examples GitHub repository where you can fork the things and play around with the stuff. And this is quite important thing, which in the real time we will be regularly dealing with. So the as it is Apache Nifi is open source, all the processes will be available in the Nifi NAR bundles. So this website, we can go and see all the processors, how they are coded. If something modification needed for our particular or personal use case, then we can go and fork it, do the changes, generate our own NAR files. During our course curriculum, once we had done a milestone, a particular milestone, we will be having mock interview 1, and post completing the complete projects and all, we will be having mock interview 2. And for the sample mock interview purpose, we will be providing enough blocks and questionnaires where you can see how the questions on Apache Nifi usually can be, and you can prepare with them. So there will be 2 mock interviews throughout the course. So that's it for this introductory demo. So there are a lot of things waiting during the course curriculum. So lots of hands-on. I will just open and show how the UI interface look like. So this is the base Apache Nifi interface, which is running on my, as I said, like a Linux system. So we can see like ask. So let us take a base use case. Now let's say I just wanted to copy a source, get file. Okay. So I just wanted to make this thing, and I wanted to place one more processor here called as maybe a put file. I think, okay. So these are the base UI what we have. So during our course, once we understand the basics of Nifi, then we will be playing around with the minimal use cases. What this menu header is, what are these monitoring look like, and if you wanted to generate some templates or group them, so we will be using these complete user interfaces to play around with this. Thank you, Farno. So looking forward to catch up you on the regular sessions. Thank you.